Assalamualaikum. Assalamualaikum and hi semua. Okay, this is our last chapter, chapter 5, which is partial differential equations. And then in this partial differential equations topic, we are going to discuss the three main things. Okay, first of all, we want to know the basic terminologies. Okay, the basic terminologies, which is the first one is what is the partial differential? What is the partial derivative first, and then we proceed to the partial differential equation. First partial derivative, and then we go to the partial differential equation, and then we want to know the order of the equations, okay, of the partial differential equation, and then what is the linearity, linear or non-linear of that kind of equation, and the concept of solution. So these are the basic terminologies of the PDE, okay, and then we proceed to the partial derivative. Okay, we go deeper. So what is partial derivative? On how we can obtain the partial derivative? What is the partial derivative means? Okay, in real situation. Okay, and then we proceed to the partial differential equations. In the partial differential equations, we just have one method in this topic. We just discuss one method to solve for the PDE, which is the method we call it as separation of variables method. And for the separation of variables method, later on I just call this one as SVM. Okay, and the SVM, we want to solve for the basic equation, the heat equation, and the wave equation. So we have three types of equation that we try to apply the SVM for that specific kind of equation. Okay, so without any delay, I just go to the partial derivative. So what is partial derivative? Okay. If you still remember, during our high school level, during our matriculation, as well as during our math 1, right? Okay, during our math 1, you already been given, let's say, given y equals to x squared plus 1. Okay, tak nak lah. Given that y equals to x squared. Okay, and then the teacher asks you to find the first derivative of y. So you are given, so that you just differentiate y with respect to x with this kind of notation d. Okay, d equals to 2x. Okay, note that during our previous introductory of calculus, we know that you are given a function y, and this x is your independent variable, dependent and independent variable. You just have one independent variable. Okay, so if you want to compute the first derivative of this dependent variable with respect to your independent variable, so you just use this notation d dy dx equals to 2x. So that is your solution. Okay, what does this mean? This one. This means that you want to find the slope of the tangent line of a curve, right? So for example, this is your function y equals to x squared, so that you can simply find the slope of the tangent line of the curve like this, right? Okay, so that you will have these 2 points, okay, these points and these points, so that you can obtain the slope of the tangent line of a curve at a specific point. Okay, very easy. So that is first derivative. Itu pun kalau ingat lah. Ingat kan? Tahu kan? You differentiate once, so that is your first derivative, and then that is actually you want to find the slope of the tangent line of a curve at a specific point. Okay, alright. So now in this topic, in this partial derivative, means that you are given a function, but your function consists of more than one independent variables. Okay, so that is the simplest way that I can tell you. Okay, for example, you are given a y. For example, y equals to x squared t. Okay, previously you just have one independent variable here, this one, but this time you have more than one independent variables, which are your x and t. So now, if you want to differentiate this function, you need to differentiate this function once with respect to specific independent variable. Okay, if you want to differentiate with respect to x, so x lah, then x will vary, but your t will become a constant. So when you differentiate the constant, give you 0. Faham tak? Okay, so for example, you want to differentiate y, you ask yourself, I have x and t lah. I want to differentiate with respect to what variable? Okay, I want to differentiate with respect to x. Okay, but note that since you have more than one independent variables, when you want to differentiate, this is not the correct notation. Okay, the notation is del. Okay, del y, del x. This is to show that you want to differentiate with the variable where your variable is more than one. Independent variable, your independent variable is more than one. Understand? So this is just to differentiate between this one and this one, d and del. Okay, so please use the correct notation. Okay, so when you differentiate your y with respect to x, this is equivalent to del x. Copy back your y. Your y is x squared t. When you differentiate with respect to x, x will become your variable, but your t here will become a constant. Differentiate constant will give you 0. X squared t, I just apply product rule here. Okay, so remain your x squared, differentiate constant. Differentiate constant give you 0 plus t, remain your t. This is just like u and v. Okay, remain your u, differentiate your v, plus remain your v, differentiate your u. Differentiate your u here is differentiate x squared with respect to variable x. So you have 2x. So this one is 2x t. Okay. In short, what I can say is when you differentiate with respect to x, your t here will become a variable. When you differentiate the same thing, when you differentiate your y with respect to your t, your x square, your variable x will become a constant. Okay, so now remain your x square, differentiate t with respect to t so that you have 1 plus, okay, remain your t and differentiate x square with respect to t, means that differentiate constant with respect to t, it will give you 0. So you just have x square. So the most important thing is use the correct the notation of your differentiation, okay, derivative, okay, partial derivative, and then when you differentiate with one variable, okay, the other variable will become your constant. Since you have here in my example, I have two independent variables, means that your differentiation can be up to second order. So this is your first order, you can differentiate this one once again. And you can do mixed partial derivative, we will discuss later. Okay, so that is the basic terminologies of partial derivative. Okay, so but we want to know what is just now when we differentiate this one, we know that this is we want to find the slope of the tangent line of a curve at a specific point. But what about this one? Okay, what about this one? We want to differentiate, we differentiate with respect to the specific variable. So what does it mean? Okay, when you have more than one independent variables, for example, you have two independent variables, okay? So when you plot to x, y, z, for example, in 3D, in 3D you have a sphere, okay? You have a sphere. Can you please imagine you have a 3D, kita panggil lah, real thing that you hold just now. Okay, katalah, let's say you hold a ball or balloon. You hold a balloon and then you put it here. Okay, so this balloon or ball is in 3D, in 3D. So I put like this. Okay, so now you hold the balloon or the ball and put it, let's say, at this one, at this specific plane. Okay, You have x, y, z, okay, and you put at the yz plane. Okay, so now, when we try to find the first derivative, what does it mean? What does it mean? It means that you still want to find the slope of the tangent line of a curve, like here. If you have this, let's say this is your curve, okay, when you want to find the slope, so you just take it here, right? But notice that you have a ball, okay? When you put at this point, let's say this point, nampak this point, you can put this is as your tangent line. You can also put this one as your tangent line. You can also put like this as your tangent line. You can also put like this here, this way as your tangent line. This means that you have infinitely many solution of your tangent line. Not solution, the direction, okay, of the tangent line of a curve at this specific point. Okay, so that later on in math 3, I don't want to discuss more about the directional derivative here, because the directional derivative you will learn during your math 3 later on. Okay, so what I just want to tell you is, if we want to find the first derivative, okay, for the function where you have more than one independent variables, you must differentiate at the specific variable, independent variable, and the other variable will become constant. Okay, so it is related to the directional derivative, which is will be discussed in your math 3. Okay, so just we just keep it for a while. Okay, but the other term that I want to tell you is, when you try to find the first derivative, when you find the first derivative of the partial derivative, okay, first order of the partial derivative, it means that you want to find the tangent line of a curve, or it is actually you want to find the slope of the tangent line of a curve at a specific point. This is the word. Okay, I can ask you, find the slope of this function. Find the slope means that you need to find the first partial derivative or first derivative. Understand or not? Okay, so I can ask you by using this term. Okay, so next, that is partial derivative, and we go to the what is PDE? Okay, partial differential equation is PDE. Okay, partial differential equation is an equation which contains at least one partial derivative of an unknown function with several variables. Means that you have a partial derivative, and then the partial derivative consists of more than one independent variable. So that is what it means by partial differential equations. We go to the order and linearity. What is order? Order is the highest derivative. Highest derivative that appears in your equation. Okay, and linearity, look at the definition. Your equation is linear if the equation is algebraically linear and the coefficient of the solution and its derivative are the function depends only on the independent variables. Okay, ayat dia. Linear, the coefficient of the solution and its derivative are the function depends only on the independent variables. Look at this function. You have u, okay, and then you have t and x. T and x are your independent variables. Okay, and this equation is said to be linear because u sub t, u sub x, where t and x are your function u only depends on your independent variables. So that is linear. Okay, the next one here is u are your function. U is your function. U sub t. T is your independent variable. It is still linear. U sub x, sorry, 2u sub x, u sub x is still linear, but the existence of this single u turn this equation becomes non-linear. This is non-linear. Why? Because this u is just u, but this u is not depends on the independent variables. Your independent variables are x and t, but you just have u. U, what is u? U. So the existence of the u turn this equation becomes a non-linear equation. Okay? Alright, so now look at the example. Determine the order of this equation first. Determine the order. Okay. You have u sub t. The highest derivative u sub t is this one, u sub t is del u del t. This one. Okay? So means that you try to differentiate u, okay? You try to differentiate this u with respect to t. Note that this t consists of more than one independent variables lah, this u. Okay? So the order of this equation is, this one is del u del t. So you just have first order. So this one is first order lah. Okay? First order, the order of this function is 1. Okay, so next, what about the this one? What about the linearity? Linear or non-linear for this kind of equation? So this equation is linear. Okay. So next, we go to this one. You have u sub t, u sub xx, and then ex. So what is the order of this equation? So the order of this equation is 2, because the highest degree of this equation is 2. So this one is del u del t plus del square u del x square equals to ex. So this equation is still linear. Okay. Alright. So next, we go to this one. We go to the, okay. So this one, this equation, the order of this equation, the highest derivative is 2, right? So the order is 2, or the second order. And then, is it linear or not? So this is still linear. Okay, because this e pun dalam x, and then your u with respect to t, your u with respect to x. U and x are the independent variables. Okay. Proceed to the next one, u sub t plus 6u ux plus uxx, x, uxx. So this one, the highest derivative is 2. Okay, so that you have second order. Alright. So is it linear or not? Is it linear or not? So for this kind of equation, you have a non-linear because of the existence of ux. Alright. Okay. You can learn more from the textbook, okay, about the order, okay, the order and the linearity or the non-linearity of that specific equation. Okay, so I give you extra notes on partial derivative here. Okay, this is just what we have discussed just now. Okay, f sub xx is actually del square f del x square, just the same thing as we discussed just now. Ut is del u del t. It's just a matter of the way you present in mathematical form. Okay, so if you have utt, so this one is del square u del t square. Okay, alright. So next, now you have, suppose that f sub x equals to this one. Okay, this function, and then find f sub x, f sub y, f sub xx, f sub yy, and f sub xy, and f sub yx. Okay, now look. This is your first derivative of f with respect to x. This is your first derivative also, but this time with respect to y. This is your second derivative or second order with respect to x. Both with respect to x. Okay, this one is second derivative with respect to y. This one and this one we call as mixed partial derivative, because first of all, we differentiate your function with respect to x. After you get the solution, you differentiate again with respect to y and vice versa. Okay, you can look at from here. I just leave this calculation for you because you you just need to apply the product rule, and then when you try to differentiate with respect to x, the other variable will become a constant. Differentiate constant will give you 0. So you can try to understand from this calculation. Can you do this for me? Not for me lah, for you lah. Okay, boleh eh? Alright, so the same thing goes to this one. You can try on this. Okay, I give you now I can give you a situation. In partial derivative, I can straightforward give you a function like this, and then I can ask you to find out the first derivative like this. Okay, if you are given two independent variables, so I can ask you up to second order. This one like this, all this one. Okay, and then I can also ask you with this kind of situation. I give you a situation and you try to create and try to do try to take out what are the question want you to do. Okay, for example, this one. You are given a function, but this function comes from the situation. Okay, and then the question asks you find the monthly number of antibacterial filter that can be produced with 20 skilled researchers and 35 unskilled workers. So you need to find out, what is skilled researchers? What are the variables that represent skilled researchers? Okay, skilled researchers is your X. Unskilled workers is Y. So in this situation, Z is your function and your independent variables are X and Y. So from these questions, I want you to try to understand how you can get this one. Okay, so this is one kind or one way of asking you on partial derivative. Okay, cuba Okay, before I forget, one more thing on partial derivative. Partial derivative just now is this one. If you still remember, I've told you about when you are given more than one independent variables, when you try to differentiate at first derivative, it means that you try to find the slope of the tangent line of a curve at a specific point. Still remember? Alright, so you look at this question. Find the slope of the tangent line of a curve of this one at the specific point 2, 1. You see? Look at this question. If you don't understand the terminology of the slope, means that you don't know how to solve for this problem. Actually, this question is just asks you to find the first derivative of f. And why the question asks you slopes, not slope. Slopes means that you have here two independent variables. So that you need to find first derivative of each of the independent variable, which is del f, del x, and del f, del y. After you get del f, del x, okay, you get the solution. Then only you put at the specific point 2, 1. Then you get the solution. What is your del f, del y? You get the solution, and then the specific solution here substitute with point 2, 1, where x is your 2 is your x, y is 1. Okay, equals to 1. So that is what it is meant by this kind of question. I can also ask you this kind of question lah lepas ni kot kan. Kalau saya saja nak tanya aku boleh kan? Why not, right? Right. So for question 1, let the temperature T be a function of time, longitude and latitude. In your own word, what can you describe about del T, del T? Okay, explain your solution based on your understanding in partial derivative, and the explanation must include all the parameters. Partial derivative and all the parameters. What are the parameters that you have? T, and T, X, Y. Your T here, T is your function. Okay, T is your function. Okay, and then you have T, X and Y. Ada 3 lah parameter kat situ. Alright. So now, when you are given del T, in partial derivative, it means that you differentiate the temperature with respect to T, time. Okay, T is time lah. Okay, so which means that in partial derivative, we say that T here, the T time will vary and X and Y are constants. Go back to our definition of partial derivative. You differentiate with one independent variable, the other independent variables will become constant. So use the definition of the partial derivative. So my explanation just now already include all the parameters. Okay, so that is the quick discussion on partial derivative. I am not really afraid about the partial derivative as long as you know how to shape your function very well. Okay, and apply the product rule lah semestinya. Okay, so that is the end of our discussion on this part. Okay, oh belum. Ini cepat sangat. Tadi dah janji kan. We want to discuss on the concept of solution. What does it mean? It means that you have a solution. Okay, solution here. This is your solution. U is our solution. U of a independent variable X and T equals to E negative 2T cos X is the solution of this one. So you must show that betul ke? This is your solution of this partial differential equation. Okay. Okay, so what you need to do is, in order to prove, to show, to verify that this U is the solution to this one. Kalau awak tak nampak, kalau dulu previously we have dy dx minus 3y 3xy equal to 4x square plus 1, for example. This is first order You try to find the solution is y tau. Ingat tak? You do lah linear y is your solution. So what we need to do is we differentiate once, we substitute back into this one, and then put x and put your y, which is your solution. Okay, and is it equals to 4x squared plus 1, right? So the same thing here. Show that this one is the solution to this one, so which means that you need to differentiate with respect to t minus 2 multiply by differentiate your u here with differentiate your u with respect to x twice, and then is it equals to 0? If yes, so means that this is your correct solution. So I don't want to show here. You just refer the textbook, and I strongly believe that you can solve for this one. Okay, if you can solve for the partial derivative at the very beginning of our discussion, means that you can solve for this one. But the concept here is, I just want you to understand that this is the concept of solution. Given a solution, you need to prove that this is your correct solution by substituting into your function. Okay, so differentiate twice with respect to t, differentiate twice with respect to x, and then plus 8. This u, take your u here. Take your u and put it here. Is it equals to 0? Okay, left hand side and right hand side. Left hand side and right hand side must be equal. So that is meant by the concept of solution. Madam, let's say I try to differentiate and I substitute into this function, and I notice that left hand side is not equal to right hand side. What happened? It means that this u is not the solution to the function. So that is what it means. Okay, so that is the end of solution of the first part. So we will continue on the second part of our chapter 5. Thank you.